All right, I'm going to recap today what we went over in terms of proving triangles congruent. So we went over three basic methods. So with proving triangles congruent, we had the SSS postulate, the S postulate. But what did SSS stand for? Side. Thanks. Can't help us today. So we had the side postulate. Then we had the SAS postulate. SAS. SAS stood for?
Side, angle, side.
Thank you. And again, what was special about the angle?
It was in between the sides.
Yeah, it had to be the included angle. So the order here was important. And then our last one that we went over today was?
Angle, side, angle. Yeah!
And again, this order was also important. Why? Because the
Side was in between
sides
the
in the,
angles.
so it's the included angle and the included side. And by that we mean if I had a triangle, if I'm talking about these these two sides, this is the included angle, which would give us side, angle, side. If it was an angle up here over here, wouldn't work out too well. If I flipped it around, same thing when we're talking about the angles. If I look at a triangle and I say we're talking about this angle and that angle, the included side is the side that connects those two angles, the side that is common between both those two angles. So that would be angle, side, angle. I want to go through a few proofs dealing with the side postulate, the side, angle, side postulate, and the angle, side, angle postulate. Now, a lot of times what's going to happen is we've got to look at the given information, see if we can manipulate it anyway, whether it gives us an angle congruent to an angle or a side congruent to a side. And then sometimes to get those things that are not in the given, we would use a reflexive property if two triangles shared a common side, or vertical angles. So if I set this up this way, and we could look at this diagram a couple different ways. Let's call this E. So let's suppose we were given E is the midpoint of segment AD. Let's suppose we're given AB is parallel to CD. And we're trying to prove triangles congruent. We're going to try and prove triangle ABE is congruent to triangle DCE. Now, as we set this up, statements, reasons, what are we going to start off with?
Given.
The given. We always start off with the given, right? 99% of the time. So E is a midpoint of segment AD. That's going to tell us something. And we've got some parallel lines. That's going to give us something. So if we use E as a midpoint of segment AD, what does a midpoint give us? My peanut gallery doesn't know. So if E is the midpoint of segment AD, a midpoint divides a segment into
two
congruent parts.
Congruent.
How do we know that? Definition of
Midpoint.
midpoint. So by using the definition of midpoint, I can say AE equals DE. Now, I said this in class. As we go through this, if I've got a segment congruent to a segment, what should I put in parentheses next to this? An S. Because if I'm going to use SSS, SAS, or ASA, I got to have all those pairs up here. I'm also given some parallel lines up here. Let me highlight these. I don't know if this will pop out in if I highlight these two lines as being parallel, what kind of angles do we have with the parallel lines? Well, I got a transversal going this way, which would give me alternate interior angles. I got a transversal going this way, which would give me alternate interior angles. But I have this side. Now, right now, our only three choices are SSS, SAS, or ASA. I can't get any more sides, so SSS is out of the picture, and I can't get any more sides, so SAS is out of the picture. So I'm trying to find angle, side, angle. So I either have to find out something about this angle in relationship to this angle, or this angle in relationship to this angle. Well, I've got parallel lines giving us alternate interior angles. It makes that Z shape. So I could say angle A is congruent or equal to angle D. When I get an angle congruent to an angle, what do I want to put in parentheses here? An S. And if we were doing a little checklist here, we could be like, check, use definition of midpoint. Now we just use parallel lines. What did we use? Parallel lines give us
Parallel implies anchors.
Man, they can't even speak right. Parallel lines give us alternate interior angles congruent. So it's like, check, we got that one done. So now I've got an angle, a side, and a side. What else do we have here?
Vertical.
Vertical angles. If there's nothing there, how would I name this angle?
1 and 2.
If there's nothing there, we could throw some numbers in there. Otherwise, I'd have to say angle AEB or angle CED, which isn't wrong. It's just easier to use numbers. So now I can throw in here angle 1 equals angle 2. There's another A. 2 congruent marks, 2 congruent marks. Reason? It's that vertical angle theorem. Vertical angles congruent. So now, what do I have in this triangle? I have 2 angles and the included side. What do I have in this triangle? I have 2 angles and the included side. Do we have enough to say the triangles are congruent?
Yes.
Yes, by ASA. And this is sort of like the checklist. If I'm using ASA here, then somewhere above this I better have an A, an S, and a different A, which we do. We have it all covered. So now I can put the triangle congruent statement. Triangle ABE is congruent to triangle DCD. There's an example of proven triangles congruent with angle, side, and angle. What are we at? We're at 6 something. I can do another one here. So let me erase this. Is the party over? No, the party's still going on.
Did you pick that one?
Yep.
Good.
Let's do an example of one. This is one that we might see a lot. Suppose I had something that looked like this. And then let's name this thing. Won't be boring. A, B, C, and D. Let's number some angles in here. And then let's have a little, and then again, we're going to have a given and a proof. We could put in the given here, let's say that AC bisects angle DCB. And let's put in here DC is congruent to DC. And now we're going to try and prove triangle ABC is congruent to triangle ABC. Again, we're going statements and reasons, 2-column proof. Start off with the given. Now we're going to throw in here AC bisects. If they're telling us something bisects an angle, what are we going to use as a reason?
Definition of angle bisect.
Definition of angle bisect. They're also telling us 2 segments are congruent. So now, again, the first thing you look at, in the given, do they give us a side or an angle? Well, they're giving us a side right here. So I'm going to put an S in parentheses next to that. And I'm going to come up here and I'm going to mark those 2 off congruent. They tell us something bisects an angle. So it's like bisects an angle. I better use that as either as a reason or apply something to it. So if they tell us something bisects an angle, we're going to use definition of
Bisector.
angle bisector. What's an angle bisector like? It's sort of like the midpoint of an angle, is it not? A midpoint gives us 2 equal segments. An angle bisector gives us 2 equal angles. Now it's bisecting this angle up here. So it's dividing this angle into 2 equal parts. So I can say angle 3 equals angle 4. What should I put in parentheses next to that? An A. I got a side, I got an A. So again, if I think back of what we're trying to use here, these are our choices so far, right? So I got an A, so I got like 2/3 of this one and 2/3 of this one. It's like, forget this one. I can't find anything else about any of the other sides. Well, not any of them, but all 3 of them. I've already got 2/3 and 2/3, so I either got to say, can I find something else out about the side that would make this the included angle? Or can we find out something else about this angle?
No.
So, now what do I know about the other side?
They're reflexive.
It's the same in both triangles, right? Like if I said triangle on the left, it's segment CA. Triangle on the right, it's segment CA. What lets me say CA is congruent to itself?
What? Oh, reflexive.
Reflexive. So we got reflexive here. S there. We have enough to say the triangles are congruent?
Yes.
Yeah, so now I can say triangle, what do we put up there? ABC is congruent to triangle ABC by Again, side, angle, side. I got the same thing over here. Side. It's got to be the same. Like if you get done one triangle and the other and they don't match up, they're not done.
SAS.
Postulate.
What?
Yay.
Postulate.
They're all
Yeah.
postulates.
I heard that.
Thank you.
POS.